Hello and welcome back. Example 2. For the following circuit at t equals 2 seconds, find the instantaneous power for the inductor and resistor. Note that we are giving this circuit in the time domain where the source is at 5,000 radians per second, and we need to convert it to the frequency domain. So we are going to rewrite the source as a phasor, 30 with an angle of 0 degrees. The impedance of the inductor is going to be j omega L. The impedance of the capacitor is going to be negative j over omega C. And the 200 ohm resistor will remain as 200 ohms. So negative j over omega C is equal to negative j 100 ohms. J omega L is equal to J 150 ohms. So the first thing we're going to find is the voltage across the inductor, which is in parallel with the voltage source. So it's 30 with an angle of 0 degrees. And the current through the inductor is V over J 150. So the current through the inductor is given by 0.2 with an angle of negative 90 degrees. Next, we're going to find the voltage across the 200 ohm resistor using the voltage divider. So 200 over 200 minus J 100 times 30 angle 0 is equal to 2.68 with an angle of 27 degrees. The current through the resistor is going to be the voltage divided by 200. So the current through the 200 ohm resistor is 0.134 with an angle of 27 degrees. Next, we're going to find the voltage across the capacitor using the voltage divider again. So the voltage across negative J 100 is negative J 100 over negative J 100 plus 200 times 30 angle 0, so that the voltage across the capacitor is equal to 13.42 with an angle of negative 63.43 degrees. And the current through the capacitor is the voltage across the capacitor divided by negative J 100, which is equal to 0.134 with an angle of 27 degrees. So first we are going to find the reactive power for the inductor, which is 1/2 Vm sine of theta V minus theta I, which equals 3 var. Next, we're going to find the instantaneous power for the inductor, which is negative Q sine omega t, or negative 3 sine 1000 t. And note that should be sine 2 omega t in watts. Negative 3 sine 1000 t in watts. And at 2 seconds, we get negative 2.79 watts. The average power for the resistor is given at 1/2 Vm cosine theta V minus theta I, which is 0.18 watts. And the instantaneous power, PR of t, is given by P plus P cosine 2 omega t, which would be 0.18 plus 0.18 cosine 1000 t. And then we evaluate that at 2 seconds, where the power at 2 seconds is equal to 114 milliwatts. Now let's do the capacitor. The reactive power for the capacitor is 1/2 Vm sine theta V minus theta I, which is negative 0.899 var. And the instantaneous power for the capacitor is negative Q sine 2 omega t, or 0.899 sine of 1000 t var. Then we find the power at 2 seconds for the capacitor, and we find that that equals 0.836 watts. Example 3. A trace from an oscilloscope is shown in the following figure. The voltage channel was set at 5 volts per centimeter, while the current channel was set at 100 milliamps per centimeter. Determine the power associated with the circuit and the energy consumed in 1 minute. So the first thing to note here is that the voltage leads the current, and that we're going to estimate the amplitude of the voltage and the current by estimating how many boxes does the amplitude or the peak cover. So for the voltage, that represents 3.5 boxes or 3.5 centimeters. And for the current, that represents 3.25 boxes or 3.25 centimeters. So now we can use the scale factor to find the current. So the current is equal to 3.5 times 100 milliamps per centimeter. So the maximum value for the current is 350 milliamps. The maximum value or amplitude for the voltage is 3.25 times 5 volts per centimeter. So Vm is equal to 16.25 volts. So note that IRMS is equal to I magnitude divided by root 2, so it's 0.2475 amps. And VRMS is V magnitude divided by root 2, which equals 11.31 volts. So we are going to use our formulas this time in terms of RMS. But first we need to find the phase by using delta T. And we see that delta T is 0.8 centimeters. So we can use that phi equals omega delta T. So next we are going to find the period. And we see that in one period, our signal is 10 centimeters or 360 degrees. So we can use the fact that we have 36 degrees per centimeter to find the value of the phase shift, where theta is equal to 0.8 centimeters times 36 degrees per centimeter. And we get that the phase shift between our two signals is 28.8 degrees. So the power, the average power, is PRMS, VRMS, IRMS cosine theta, where theta is the difference between the two signals. So it's 2.5 watts. And the energy is the integral from 0 to 60 seconds of P d tau, or 2.5 d tau, or 2.5 times 60. So the total energy is 149.5 joules. Thank you and come again.